Today we're going to talk about how to identify vertical and horizontal shifts and also reflections of a function. So the first thing we're going to talk about is vertical and horizontal shifts. So vertical meaning shifts that are up or down, and vertical meaning or horizontal meaning shifts that are left or right. And we're going to start by talking about this with general function notation. General function notation meaning that I don't know what function we're talking about specifically, so I'm going to write y equals f of x. And f of x could be any of those family of functions that we talked about last class. So if I shift this function, I'm going to start with a left or an up or down shift. If I shift this function up or down, it means that the outputs, the y values, are going to shift up or down. And f of x itself represents an output or a y value. So to shift it up, I'm simply going to add a number to it. And whatever number I add to it, it's going to shift up that many spaces. So the function shifted up will look like this with a number added. And I'm just going to put the number symbol there because that number could be anything, any number. If you shift a function down, it's going to look exactly the same, except it's going to be y equals f of x, the function, but with the number subtracted. And whatever number I subtract means down that many units. So the key here is that the number that we add or subtract is outside of the function itself. Now, when we shift left or right, it looks a little bit different. So you see how the left or right, that's like the x-axis. The x is inside of our function right here in the parentheses. So if I want to shift something right, instead of writing f of x and closing the parentheses, I'm going to keep inside the parentheses and I'm going to add or subtract my number inside the function. Now the key here with left and right is that when we shift left or right, we actually use the opposite symbol of what we're intending to do. So right is normally a positive number. We are going to subtract a number. That means that we shift right, whatever number that is. And then if I shift left, it's going to be the same, y equals f of x, but I stay inside the parentheses, I don't close, and left would be adding some number. So this is very abstract right now. So what we're going to do is talk about this with one of the family of functions that we did yesterday. So the family of function that we're going to talk about is the quadratic function, pretty common. So here is our quadratic function. So this is our general quadratic function, y equals x squared. I'm going to write y equals x squared in the middle here, and I'm going to shift this function up, down, left, or right. So what I like to do is think about the function itself is whatever I input into it, squared, right? So when I think about what we talked about with our general function, we said to move something up or down, we leave our function alone and we just add a number at the end, or leave our function alone and subtract a number. So I'm going to take our function, leave it alone, y equals x squared, and add a number to it at the end. And that means that I move it up whatever number I add to the end. And if I leave our function alone as is and subtract a number, that means it's moving down. Now with left or right, it's a little bit trickier. So I want you to think about this function. I'm just going to write it over here. Whatever I put in for x, it's saying that x is squared, right? So if I want to move something left or right, I have to put something inside this function with the x and then square it. So a little bit different than squaring the function, the quadratic, and then adding. So to move something right, I would say y equals, and this is my function, right? X squared, something squared. But I said in my last slide that to move something right, we would subtract a number. So if I wanted to move this right, I would write x minus some number squared. And if I wanted to move it left, I would say y equals, there's my function, something squared, I'm going to do x plus some number squared. So this is just like our general key to think about how to move functions left, right, or up or down. And remember, x squared was just one example function, but we could do this with any of the parent functions or the family of functions that we learned last class. Within the function means that if we look at our general notation, that it's shifted left or right, and these are opposite symbols. So right would be a minus symbol, left would be a positive symbol. All right, so now we're going to talk about reflections over the x-axis. Okay, so for reflections over the x-axis, we're going to do a general function notation first, and then again, a reflection of one of our specific parent functions. So the general function notation would be y equals f of x, so that's our general function. If I want this function to be reflected over the x-axis, that just means that all of the y values are reflected. If they were above the x-axis, they would be below. If they were below, they'd be above. So it means all of our outputs are opposite. So f of x represents an output. To flip it over the x-axis, I just put a negative in front of it. So that's the general notation. Now, if I wanted to make y equals x squared opposite, my function is x squared. So to make that opposite, I would just do a negative. And actually, you have some options here. I like to put the x in parentheses. You don't have to, but I like to put the x in parentheses so I know that x squared as a whole is made opposite. That would flip it over the x-axis. All right, so we have some examples of just visuals of what our parent functions from yesterday would look like if they were flipped over the x-axis. So our first graph, if you recognize the general shape, I'm going to actually draw the parent function with a dotted line. So the first graph is our V-shaped absolute value graph. And this is our parent function. And what happened to the parent function is that every point, so if I pick a point, this one, 1, 1, do you see how that point is reflected over the x-axis? And it became the point 1, negative 1. Then if I pick another point over here, that also was reflected over the x-axis. So that's how I know that my original function, my parent function, which was the absolute value of x, became reflected over the x-axis and became the function y equals the absolute value of x, right here, with a negative symbol in front of it. So, next function, this is our general linear parent function. So my original linear function would be the dotted line like this, but I know that my original linear function would be increasing from left to right, and I see my red line right here is actually a reflection over the x-axis. And so since that was reflected over the x-axis, I can see that the equation looks exactly the same as the original. The original is, again, I'm going to write it up here, y equals x. You'll see that the new function is y equals negative x. Then the last example is our cubic function. Normally, our cubic function looks like this. It increases from left to right like that. But I see that this one is decreasing. It was reflected over the x-axis. So if my parent function was y equals x cubed, my new function is the same thing, just with a negative symbol up front. That's reflected over the x-axis. So hopefully that helps you visualize what a few different examples of parent functions look like when they are flipped over the x-axis or reflected over the x-axis. All right, so now we're just going to do a couple examples. And in these examples, the directions say, given the equation of a transformed equation, part A, identify the parent function. So the parent function are any of those functions we went over last class. Part B, identify the transformation. And when I say identify the transformation, that means that I want you to tell me whether these functions are shifted up, down, left, right, or whether they are reflected. And if they're shifted up, down, left, or right, we will also specify how many units they are shifted. All right, so the first one thing to notice is I don't see any negative symbols out front, right? So this is a square root function. So part A is to identify the family of functions or the parent. So this is a square root function. I don't see any negative symbols out front of the square root function, so I know it's not reflected. And the only shift that I see is right here, that +4. Now that +4 is inside the square root symbol. That means it's within the function. And if it's within the function, if I go back a couple slides, okay, so this is inside and it's a +4. That means that this is actually left 4. So this is a square root function shifted left 4 units. All right, next one. So I recognize right away that this has absolute value bars. That means that the parent function is an absolute value function. And then I'll look at the two shifts and I'm going to highlight them both. So the first shift, I'm going to use the same color, the red, is inside the function. The next shift, the -3, is outside the function. So the red shift inside the function is left or right. It's a positive, so that's actually the opposite of what we would think. That means left. So this is shifted left 1. The blue shift is outside the function, so that means up or down. And it's negative, so we know negative means down. So this is down 3. All right, our last one, I recognize the exponent of 3. I know that that's a cubic. So we'll say that the parent is a cubic function. I only see one shift. I don't see any negative, so that means no reflection. I see one shift, and it is outside of the cubic exponent. It's outside of the exponent 3. That means up or down. And up, when we're talking about, or positive when we're talking about up or down, means up. So +5 means that this is shifted up 5. All right, we're going to do one more example together, and then I'm going to have you guys try the last two on your own. So we'll do number 4. Number 4, I recognize the quadratic or the exponent of 2. That means my family of functions is a quadratic. And I notice something I haven't seen yet. I notice a negative symbol out front of the function. If you see a negative, that means that this is reflected. So you could just say reflected. I'm going to be specific and say vertically reflected. Vertically reflected means it's reflected over the x-axis. That's the only type of reflection we're going to talk about in this class. And then lastly, I see a +6, and that +6 is outside of the function. It's outside of the x squared. So that means it's up or down, and a positive means up when we're talking about up or down, so up 6. All right, so I want you to pause the video and try these two on your own. So again, list the parent and the shifts for both. Okay, so hopefully you paused the video and tried this on your own. I'm just going to put the answers on so you can check if you did them correctly. So the first one is linear. It is right 4 and up 1. The second one is absolute value. It is vertically reflected, and there are actually no other shifts for this one. All right, next you will try some practice with this material. Good luck.